Hello, Math 1060 class. Let's do the test 4 review, number 1. We are flipping 4 coins. Outcomes in the sample space are represented by strings of H's and T's, such as TTHT and HHTT. How many elements are in the sample space? Well, we are flipping 4 coins. And remember, each coin has 2 possible outcomes. So using the fundamental principle of counting, it looks like there are 2 to the 4th or 16 elements in the sample space. Express the event there are more heads than tails as a set. And they really mean an event, I think. So let's try to do this systematically. There are more heads than tails, but we just have 4 letters. So if there are more heads than tails, we're either going to have 4 heads or 3 heads. So we can't have 2 or 1 because then we wouldn't have more H's than T's. The only way we can get 4 H's, though, is if we have a string of 4 H's. That's the only possible outcome in that particular case. Well, if you have 3 H's, that means you just have 1 T. So your T could come in first place, second place, third place, or last. So it looks like this is the event. And that one is multiple choice. Let's do the next one. The probability that there are more heads than tails. Well, we're really looking for the probability of the previous event. So all you have to do is count up the number of outcomes in that event. It looks like there are 5 of them, and divide by the total number of outcomes in the sample space, which is 16. So that was part C. What is the probability there are an equal number of heads and tails? So first of all, let's write down the event that corresponds to that phrase, an equal number of heads and tails. So we have 4 letters. If we have an equal number of each, that means we have 2 heads and 2 tails. So let me try to list that event. That's one possibility. There's another. There's another. There's another. And I think the H's and T's could also alternate. So it looks to me like there are 6 outcomes in that particular event. But I know there are 16 total in the sample space. So 3/8 is the probability that we have an equal number of heads and tails. So that one was kind of a long problem. Let's do another one. Number 2. Write the event yellow appears exactly once when we spin the spinner 2 times as a set of outcomes. So it looks like we have a spinner here with 3 different colors. And it says, write the event, yellow appears exactly once when we spin the spinner 2 times. And we're supposed to abbreviate red with a little r, blue with a little b, and yellow with a little y. So let's see if we can come up with the event. But it sounds like we just spin it twice. So we're just going to have 2 letters every time. Something like ry, maybe rr, b, y, and so on. But we want exactly 1 y, so it could be ry, it could be by, it could be, well, I guess it can't be yy because then it would appear twice. But the y could also come at the beginning, so it could be yr and yb. I think those are the only 4. Let's move on to number 3. A cookie is selected at random from a basket containing 14 mint cookies, 18 caramel cookies, 10 peanut butter cookies, and 28 sugar cookies. Find the probability that a mint cookie is selected. So this one is much easier than some of the other ones we just did. Well, I know there are 14 mints in the basket. So how many total are there? Well, we have 14 mints, 18 caramel, 10 peanut butter, and 28 sugar cookies. So we would just divide by the total, which is 70. But this does reduce to 7/35, which reduces to 1/5. Let's try number 4. In horse racing, a trifecta is a race in which you must pick the first, second, and third place winners in their proper order to win a payoff. If 12 horses are racing, and you randomly select 3 as you bet your trifecta, what is the probability that you will win? Assume that all horses have the same chance to win. Okay. Well, there's really only one way to win the trifecta, because you have to select the correct 3 horses in the correct order. So really the only tricky part is to come up with a number of ways to select 3 horses in general. And in this case, order is important, so this is going to involve permutations. And we have a total of 12 horses to choose from. We're going to choose 3 of them. But we would definitely use permutations. Looks like 1320 is the denominator. So that's it. Let's move on to number 5. In crossbreeding certain plants, the scientists found that flower color does not dominate as happens with peas. For example, a plant with 1 red gene and 1 yellow gene will have orange flowers. Part A, construct a Punnett square showing the results of crossing a purebred red with a purebred yellow of the same species. So here is a purebred red in that top row. And this is a purebred yellow in that first column. So it looks like all the offspring are the same. And remember, when we mix a red with a yellow, we actually get orange flowers. But that's part A. Part B says, in the first generation of plants, the probability of getting red flowers is what? The probability of getting yellow flowers is what? And what is the probability of getting orange flowers? Well, clearly they're all orange. So the probability of getting orange flowers is 1. And the probability of getting a red is 0. The probability of getting yellow is also 0. So let's move on to the next problem. That was part B of that problem. Number 6. If the odds against event E are 19-1, let me write that down. What is the probability of E is what we're looking for. Okay. So let me construct a Venn diagram to answer that question. Here's set E inside some sample space S. And it says the odds against E are 19-1. That means there are 19 ways for E to not happen and 1 way for E to happen. So what is the probability of E? Well, I have 1 outcome in E, and I have a total of 20 outcomes in the sample space. So 1 divided by 20. try number 7. This time we're given the probability of E is 0.23. What are the odds against E is the question. Okay. Well, you know, you can always convert this to 23 divided by 100 if you want to. And you can even construct a little Venn diagram if you want. Here's E. So the probability of E is the number of things in E divided by the number of things in the sample space, which is 100. So if there are 23 things in E and 100 total, then 100 minus 23 equals 77 is the number of outcomes outside of E in that sample space. But we're looking for the odds against E. So that's everything outside of E, colon, everything inside of E. And I believe that can't be reduced because 23 is prime. Let's try number 8. A television game show has 7 doors, of which the contestant must pick 2. So 7 doors total. We pick 2. Behind 2 of the doors are expensive cars, and behind the other 5 are consolation prizes. So 2 doors have cars, and 5 have just consolation prizes. The contestant gets to keep the items behind the 2 doors she selects. Determine the probability the contestant wins at least 1 car. So we're looking for the probability that she gets at least 1 car. And anytime you hear that phrase, at least 1, it's usually better to find the probability of the complement. And what is the complement of at least 1? None. So I'm going to find the probability that she gets no cars, and then I'm going to subtract that from 1. So this part's a little bit tricky. But just keep in mind we have 7 doors total, and we're supposed to pick 2. But there are 2 winners. And it sounds like there are 5 losers. So first decide how many ways she can get no cars at all. How many ways can she do it? Well, I believe 5 choose 2 is the answer. 5 choose 2 combinations. Because this is just the number of ways that she can select 2 of the 5 losers. And we would just divide that by the total number of choices. But keep in mind that there are 7 doors total and she's choosing 2 of them. So 7 choose 2 is the size of the sample space. Let's move on to number 9. This one is kind of similar. Actually, let me see. I think I was still staring at number 8. Let me look at number 9. What is the probability of getting either a diamond or a queen when drawing a single card from a deck of 52 cards? So the probability of getting a diamond or a queen. So remember, you use the union symbol whenever you want to translate English to math. You use the union symbol for the or. And the formula says this is the probability of getting a diamond plus the probability of getting a queen minus the probability of getting a diamond and a queen. So that's something you should remember for the test. So what's the probability of getting a diamond? Well, a diamond, remember, is a suit, and there are 13 of each of the suits, so 13 out of 52. But a queen is a rank, and there are just 4 each of all the ranks. There are just 4 queens. And are there any cards that are diamonds and queens at the same time? Because remember, intersection corresponds to and. And the answer is yes, the queen of diamonds. There's just 1 card like that. So it looks like 16 out of 52 or 8 over 26. And that's the same thing as 4 13ths. Let's move on to number 10. The table below relates the amount of time consumers spend shopping on the internet per month with their annual income. What is the probability that a randomly selected consumer either spends 10 plus hours per month shopping on the internet or has an annual income above $60,000? Okay, so I guess I'll have to go ahead and do the chart on this one. Just give me a minute. Okay, so the question is, what is the probability that a randomly selected consumer either spends 10 plus hours per month shopping on the internet or has an annual income above $60,000? So we see that either or expression, and remember, or corresponds to union. So we probably want to use that formula that we just used in the last problem. Well, let me make up some nice convenient notation. So they either spend 10 plus hours per month shopping, or they have an annual income of 60,000 or more. So let's use the formula. So let's find the probability that they spend at least 10 hours per month shopping. Let's go back to the chart. Well, it sounds like the total number of people that do that is 497 out of 1616. Well, how many people, or what is the probability that they make at least 60,000? Well, let's see. Well, it sounds like 499 out of 1616 make that much money. And what is the probability that they're both? Well, let's see. And remember, on this last term, you want to intersect a row and a column. You want to intersect the 10 plus column with the 60 plus row, and you end up with 195 when you do. So the last probability is 195 over 1616. Let's plug all that into a calculator. It says round to 2 decimal places. I get 0.50 to 2 places. So I think I'm going to wrap it up there. We'll have a second video for the rest of the quiz.